Well, I am super thrilled to be joined this morning by Mike Noonen. Mike, welcome.
Oh, thank you so much. A pleasure to be with you here today.
Absolutely. And for most of the semiconductor industry, you don't need much of an introduction. But if you wouldn't mind, for the couple people who may have been living under a rock for the last couple of years, can you share a little bit about your background and history?
Oh, I'd be happy to. And yeah, I've had the good fortune to be in the semiconductor industry going back to 2 micron, two metal, one poly. So those in the know can figure that out. But started off as a field application engineer back when every computer company had its own semiconductor division, and for me that was NCR Microelectronics. And along the way, we had the opportunity to work with some very interesting startups. So some of which included ones that actually came up with some of the first video telephony and USB cameras that we're putting to good use. So now, but also companies like National Semiconductor, where I ran product lines and global sales and marketing. Part of the team that after the spin out of Philips Semiconductor to create NXP, ran global sales and marketing there, and then joined GlobalFoundries, where I ran product sales, marketing, design, and quality, and there got involved with startups, as I was the one of the founders of Silicon Catalyst, and that's put me on the basically the trajectory I've been on the past better part of 10 years, working with some of the most interesting semiconductor startups, either advising, investing, and sometimes taking an operational role. And currently, I'm running the most interesting of those, as I have the good fortune to be the CEO of Swave Photonics, a spin out from IMEC, developing the world's first holographic displays.
That's awesome. And for those who aren't familiar with Swave Photonics yet, can you tell us a little bit about the company and what you guys are working on?
Oh, absolutely. And so, while everybody probably knows, holography, since we've been seeing in the movies for the better part of 40, 50 years, going back to, iconic Princess Leia, for the most part, dynamic, holograms have only existed in the movies. And the folks at IMEC, better part of 15 years ago, decided let's figure out how to actually make true holographic displays. And they tried using a lot of the various I guess legacy or existing display technology. But the trick is to do true holography, which basically you're creating essentially an image, a three-dimensional image in free space, using the interference of light waves. To do it correctly, you need tiny pixels, pixels then on the order of half the wavelength of light. And existing technologies, an order of magnitude too large. IMAX, since they used the entire periodic table of elements to innovate, realized, wait a second, we can use phase change material, what made rewritable DVDs rewritable and used today as an embedded memory. Let's use phase change material as a pixel. And what Swave was born and spun out to productize the technology that was initially developed at IMEC, and we're in the stages of introducing what we call a holographic extended reality chipset. That'll bring true holograms to the market for applications ranging from AR smart glasses all the way to displays like the ones we're using here, 3D but without glasses.
That's incredible. And you kind of spoke very quickly about the HXR platform, and you were recently honored with one of the innovation awards at CES 2025.
Indeed. We were thrilled to have our technology recognized. Given that it really is a photonics leap forward, but with CMOS economics. And so, if they like our technology enough to give us an award, wait till we actually have products. And we're looking forward to introducing this first display, which is actually going to have 250 million pixels on a tiny CMOS die. And that's going to be upcoming later this year.
Well, that's definitely exciting. What we've seen is oftentimes those kind of validation awards can really be a shot in the arm to the engineering team. Can you tell us what that's meant to you and the company and the engineering team?
So great point. And with a startup, and especially a deep tech and semiconductor startup, you toil away and you really don't necessarily get that feedback or validation that what you're building is going to be as impactful as it is. So when you work with it every day, so having CES, which is really one of the best places where new technology basically gets revealed. Having panel experts recognize what we're doing is impactful and going to make a real difference and really bring to life one of the things that we know is going to happen, because again we've been seeing it in the movies for so long. And so our team was absolutely thrilled to have this both validation as well as the feedback that we got from participating at CES and showing the technology proof points that we had demonstrated not only at CES but also just a couple of weeks ago at the SPIE Photonics West in San Francisco.
Oh yeah, we were out there as well. And so one of the things that's important to us and to me when we're highlighting companies is that the technology that they're building actually helps humanity and has the opportunity to make the world a better place. And a lot of times people hear about holographic technology and they think of consumer related use cases. But as I think big, I think about the chance to democratize access to knowledge, overall improve human well-being, and even medical advancements that can happen. Can you speak to some of those that you guys are dreaming up these days?
Well, you're so right, and when you think about computer technology and information science, humans are visual, and and the world is three-dimensional. And so if you really want to have an augmentation or really tap into where both computers and data science really can help, it really needs to basically behave in a way that that humans can digest it in a meaningful way, but also do it in a way that's natural and also not isolating or perhaps at its worst antisocial. Uh, and you think about the past 10 to 15 years, so many people are staring at their phones, and that isn't necessarily healthy, but also isn't necessarily that efficient when it comes to giving you the information that you need when you need it. And so if we think about something as simple as navigation and being able to look at where you want to go and have the directions or the information that you need basically overlaid on your reality, but also making your reality first, not the digital world first, or perhaps isolating. And I think this is where and really we saw this at CES. Being able to go ahead and do it and take something as simple as really the original augmented reality, basically prescription glasses, and be able to turn that into a display that can be this just in time information, what you need, when you need it, but also where you need it, put it in focus. That's basically what we're enabling. And you bring up the example of medical information. Being able to go ahead and whether it's having something as simple and straightforward as your heart rate, being able to display your exercising, or even the example of hospital surgery, being able to go ahead and have the ultimate and digital twin, being able to go ahead and overlay something that a surgeon needs, but they can do that while they're operating, but in context. And these are, I think, real examples, but really have been limited by the fact that up till now, the solutions that have been possible, basically using existing and perhaps legacy display technology, really have limited not only what we could display, but also do it in a way that isn't the way that the human vision system expects things to behave. And there's something called divergence accommodation conflict, and this is the technical name for why you feel a little bit seasick or wearing a pair of perhaps VR goggles for a few minutes. It's because what you expect to be in focus and how things are basically presented don't do what work in the way that the real world works. Well, holography solves that, and does it in a way that really is the ultimate in 3D visualization, but also does it computationally. And so, it has the benefit of, once you're able to do true holograms, reduce the complexity of optics, make everything, behave in the way that we expect, and at the same time reduce the cost of goods, because now we can leverage literally Moore's law, which hasn't been something that photonics has been able to tap into up till now. And so everything gets better, once someone solved this nanopixel challenge, and that's exactly what Swave Photonics is doing.
Incredible. That's exciting stuff. Thanks for sharing that. And if we're to look more broadly, first and foremost, I am such a proponent of IMEC and the investment that they have in multiple different companies in really being able to help incubate some pretty cutting edge stuff in the photonics world. A lot of the photonics advancements are happening over in Europe. And I think that if they continue to invest in that, that can be really their calling card. That they lost manufacturing to Asia, they lost semiconductors to the U.S., and I think that they've learned their lesson. Are going to really look to hold on to photonics. Now, a lot of what we're seeing from a Metatrend standpoint, though, over there is there's a lot of fragmentation, and I'm excited for photonics in general, though, because there's a lot of money that's being poured into it, largely driven by data center. Are there any meta trends that you're recognizing in photonics in general that maybe other executives aren't seeing?
Well, so great question, and IMEC, as well as other pre-competitive research groups, which have a fantastic legacy and really an amazing track record, especially in Europe, and IMEC's at the top of that list. What they're showing is, when you start to think about what problems in a different way, and tap into the material science and capabilities that a few years ago wouldn't have necessarily been possible, and in our use of phase change material as a photonic element is just a good example of that. And this really is the beginning of a whole new age of tunable photonics, where we can actually start to use semiconductor techniques and apply computation as opposed to more glass or lenses to get a job done. And this really is the siliconization of technologies that arguably haven't been fundamentally evolved since the days of Galileo, when first came up with the telescope. So I think we're on this whole new age of being able to computationally manipulate light, and this has so many different applications. Holography that Swave Photonics is focused on is just one example, but the ability now to to siliconize photonic interconnects for the data center, and chip to chip, board to board, box to box connectivity, and really move to much lower picojoules per bit transport. These are, I think, really exciting areas. But also, just opens up a whole wide range of new applications where we've either been limited by by the material science or the tools, but to institutes and clever people such as the researchers at IMEC really are opening up a whole new worlds and really new industries that we're going to be able to tap into, and I think it makes for an exciting future. And Swave Photonics is just one example of companies that are leading this lab to fab transition for new applications.
Absolutely, and I hadn't actually heard that term before, but I'm gonna steal it from you. Siliconization of photonics. I love it. Are there any either customer engagements or deployments that you are in particular excited about? Obviously, without sharing anything confidential, but that you've seen that just really get you excited of the Swave technology.
Well, what excites us is the customer excitement, because again, so many industries and markets have been waiting for holography to make this leap from science fiction or the world of entertainment to actually being something practical. And while our technology is applicable to so many end applications, what we're very both focused on and excited about is augmented reality, smart glasses. because this is, I think an opportunity that really has risen to the forefront, and the combination of this evolution to spatial compute as well as AI all come together. And it turns out that perhaps the best UI or user interface for AI might be AR. And so this is a great time to be introducing a technology and really an entirely new display capability that that makes the most of this new era of computing, the spatial and AI. So all these things are coming together at once, and this is one of those things where it seems to happen overnight. But holography was discovered in 1947 or invented by Dennis Gabor, which happens to be the same year that the transistor at Bell Labs, 1947, and one of the very first neural net papers was published. And so it's taken better part of 3/4 of a century for all these megatrends to come together, and really I think creating an exciting confluence that we're going to enjoy in this new era of spatial and AI computing. And AR smart glasses might be one of the best ways this is going to be deployed and be used not only for all sorts of commercial applications, but might end up being the next way that we interact and move away from the the smartphone that belongs maybe better in our pocket.
Well, anything that can get my 12 and 11-year-old daughters off the phones is a welcome advancement for me. Hey, if we're to shift gears a little bit, Mike, I mean, listen, you've led some of the largest organizations, some of the greatest companies and startups. You're on multiple boards. Modesty aside, you're an industry legend. And I'm curious what Dmitri and Theo pitched you to say, I'm going to invest my most valuable commodity and put my stake in the ground at Swave.
Well, first, and thank you for bringing up Swave's co-founders, because I give so much credit to to anyone who's bold enough to to start something new, and take that leap of faith, because there's no lemon law when it comes to new technology. You only find out what you don't know until you start doing it. So they're both courageous, bold, and technology, I guess. So pioneers. So first was both their enthusiasm. I found just exhilarating, and also I've had a long-lasting relationship with the team at IMEC. Going back to my days at National Semiconductor. They were also our first partner when we were launching Silicon Catalyst, and so I knew that whatever IMEC does is going to be something that is worth seriously considering. But the other part of it is way back when in the early days of video communication, I had a company called 8x8, and we were trying to make regular telephones turn them into video phones. And so for me, this is kind of the natural evolution of that journey, and instead of trying to put to a real-time video down a V.32 bis modem, 28 kilobits, going to holography, just a natural I guess extension of something that I was fortunate to be better part of 20 years ago. So for all those reasons, but most importantly, the people involved is what what both got me excited, and hopefully that enthusiasm and excitement's coming through in what I'm sharing here today.
Absolutely, it is. And you guys just closed a $20 million Series A funding in January. Congrats. And I know that leaders like you have certain criteria they're looking for in evaluating investors. Can you share what you look for and what the team is looking for in their investment partners?
Oh, so great question, and we were fortunate to have some amazing founding investors, and gratified by their both eagerness to not only continue but also step up. But we really put together a nice portfolio of traditional venture investors from Europe, and primarily in Flanders, where IMEC is based. In the U.S., so IAG, Capital Partners, for instance, as well as significant government support. We're so fortunate to have a wonderful relationship with the EU and the European Innovation Council in particular, but also we were part of the Luminate accelerator incubator in Rochester, New York. Also important to from our strategy to also bring in your strategic partner and Murata, amazing company in Japan, has joined us, and so a nice well balance of investors, but ones that also have the right level of share vision, but also have the discipline that I think deep tech investing and startups really need, and so it's a nice mix of different perspectives, as well as the right experience that can help myself, Theo, Dmitri, and the rest of our management team do what till now has not been possible, and again also leveraging the better part of 12 years of fundamental research that happened at IMEC. And that's one of the reasons that we're able to I think move so quickly, just a couple of years after founding, to be introducing products here this year, and again really embracing how a fabless semiconductor does things, but applying it now to more of a photonics application. It's a nice confluence of many things that have led to our position here, and have us be in a great position to make the most of this opportunities and the mega trends we were just talking about.
Absolutely. And typically capital resource infusion comes hand in hand with human resource growth and scaling. And I think that we would agree that talent plays a huge part in building a great company. And right now it's more competitive than ever to attract talent in the photonics space. How is Swave going about competing for the best people?
So fantastic point, and the most important asset resource for any startup and really any company is the team, and what we found is great people attract great people, and we've been so fortunate to first having an origin story with IMEC first gets us perhaps attention that other startups might not have, but we've been able to build a team that really has been a little bit on the word of mouth, but really the reputation of the team members, and that has very much a virtuous cycle, and also we've been I think open-minded and how we grow. One of the I guess silver linings of the post-pandemic world is we know how to manage and work very tightly and closely, even though we might have remote teams. I'm in Silicon Valley. Our headquarters is in Leuven. We're starting to build up a team in the Seattle area, but being able to work as seamlessly as possible, leveraging the tools that we have at hand, and that combination of being able to have the right network, but also being able to attract the best people and wherever they are in the world. Having said that, we are very both committed to making sure that we'll always have and will continue to grow in Leuven, but that flexibility and the way of working really has been an asset. And the reality is, I think best people in any industry want to go work on the most exciting and interesting problems and work with the most interesting people. And what Swave is doing, definitely captures the imagination of so many people. And then when they realize that we're making pixels that are half the wavelength of light, and doing it in a way that actually is going to make but again we've been told the future is going to be make that come to life. These are the fun problems that everybody wants to work on. So those are some of the both ingredients as well as strategies we've used to build a fantastic team, and one that really is both having fun and I think going to make a huge impact on the markets that we're going to serve.
Absolutely. If there was one key element of the Swave culture that maybe people outside of the company couldn't see easily, that you would say would be an attractive element, what would that be?
Oh, great question. And I've had the good fortune, along my career of learning what to do and also what not to do. And two things, and this is one that particularly after closing our most recent financing, it's deciding what not to do. And when it comes to deep tech and the opportunities that we have in front of us, it's quite easy to get distracted and really dilute our efforts. That's one aspect about the culture that we're looking to maintain, and it's this is something I think is necessary, either for a scrappy startup or a multi-billion multinational company. The other thing is to make mistakes quickly and be agile. And I think those are things that that you really I found have been successful, especially when you're looking to take an innovation and bring it to market. And the other part is form customer partnerships early, because there's nothing beats hearing from a customer, and we like to say a bad day with a customer beats a good day in the office. And so these are just some of the things that I found to have been recipes for success that we're really trying to live every day. And I think it really is empowering because, in the end, people want to do great things, have fun, and when you have these type of perhaps guidelines or perhaps philosophies, it just makes that even more effective and more enjoyable. But in the end, that also brings a bit of a work-life balance. Because at the end of the day, if you want to make sure that you don't lose sight of of what we're doing, but also in the grand scheme of things, how this fits with everyone's family life, and these things are important, and I think we try every day to strike that right balance, as we do what hasn't been done before.
Well, incredible. And as we wrap up, if you were talking to an engineer who is not actively looking, but that may be curious about what Swave is doing, or a customer, or an investor, how would you what would you say to convince them to potentially reach out?
Swave is at the middle, or at the center of perhaps some of these mega trends, and it turns out there's so many, I think, investors as well as individuals who have already had both an interest as well as an enthusiasm for the things that we're doing. And so it's a little bit the burden on us is to, as we kind of come out of stealth, to share more, and we're doing more of that. And Photonics West was a good example of that, where we did a couple of presentations, and so we'll do more of that in our website. Gives a real good example of the technology and how we're going to use that. And we're and honestly, it's one of the reasons why I'm so gratified to do this session with you here today, because this is a great way we find to tell our story and give a little bit of beyond the specs, if you will, a little bit of both background and flavor of what we're doing, and what the company is all about.
Well, the pleasure is mine, and debt of gratitude for your time. Always interesting to chat and get to learn from you. So hopefully it won't be too much longer. We'll have to do a second edition of this discussion. I'm sure some exciting news will be coming out again soon. So thanks again, Mike, and we'll talk soon.
My pleasure. Thank you so much.